My dear friends, before starting the session, just I want to be talk little bit about you, about the strength of material. If you very soon, I will share the detailed analysis of whole, you can say the strength of material question. Not even strength of material, all detailed solution very soon. I am going to upload over the YouTube, so you can see that one. But from the analysis, one thing I can say that most of the question has been asked from the strength of material. The quality of the question is good. Today I am going to start the strength of material, and by assuming that you don't know anything, so we will start from the basics. But in the ISRO, if you think about the question difficulty level are good, even more than gate. Yeah, the only thing is that in the gate little bit more calculation would be there. But in case of ISRO, since no calculator is there, so it will be little bit less calculative. Rest thing it will be more than the gate. So my dear friends, I am not make you feared, but I want to be just to tell you what is the reality of that exam. You in the previously last 6 lectures I have completed the engineering mechanics, and you have seen what was the difficulty level. So that thing that I want to tell you, you have to be mentally prepared that yes, good question is going to be asked. And yes, my dear friends, as being a mentor, I will help you in that which type of question they can ask and how you have to be think. Like in the engineering mechanics also you have did the same thing. So continuously, but yes, one thing that I want to tell you, more important thing is that you, my dear friends, what is happening, and especially in the classes, student think okay, I have recording classes and I will see you, I will watch that lecture later, and before that later your exam comes and all the that recording is going to be here, nothing you can do with the recording. My dear friends, only one thing I want to tell you, especially in the online things, just think like that is offline class. Once you are going to miss the class, just think hypothetically, once I am going to miss the class, I will not attend the class, just like in the offline lectures. Then you could be the very precise. Otherwise you think okay, today I have not time, I will do the tomorrow the session, tomorrow some work will, okay, day after tomorrow, and that shifting will be continue. And at the last you will find that you have nothing to do with the recording is left there. So my dear friends, if you guys are preparing, so take the decision, and before doing anything, first of all you have to be complete the lectures. Okay, if you come in the live, then well and good, that is the best things. But suppose due to any causes, it might be possible some of you are from the working background, so okay, no problem, but you have to be think like that, okay, I have only one day today and I have to be covered that lecture anyhow by today. If you have that mentality, my dear friends, then only you can do the something best, right? And if you okay, now I am going to start the session, and that is okay, that is the question number one. I will start from the question number one, first. First thing I want to tell, I will start from the zero, I will start from the very basics, right? And slowly I will increase the level. No, don't think the first question will be difficult like ISRO. Yeah, because you have to be start, so we will start from the zero, assuming that you don't know anything, and I will discuss the concept also. As you move further in the next lectures, the difficulty or toughness level slightly will get that increasing. Even you can see in the question also here, I have started from the very basic question. I have started here from the very basic question, what is Poisson ratio? I think that cannot be asked in ISRO, but you must have to be known. And as you move ahead in the same lectures I will follow, as you move ahead, some formulas are there. Now after that some numericals are there, and continuously I am going to be increase the question level. Here some numericals are there, and in the session next I will come, then I will see the different types of question. Most of the question has been asked from the three section in the ISRO. One from the Moore circle, another from the SFD BMD, a third point from the deflection or columns. That only 4 chapter, if you analyze na question, several question has been asked, right? But to getting that question concept clarity, you must have to be know what is a stress, what is a strain, how to draw the Moore circle, okay, that type of things. So why the beam is going to be deflected, what is difference between beam, bar, and column, what is short column, what is long column, Euler equation is applicable for which column, why you are going to take the I minimum in calculation PCR. So that all thing you have to be know. That's why you have to first make a foundation. Once foundation becomes strong, you can make a multi-storage building over that. But if your foundation is weak, just after one first floor, it is going to be collapse. So strong work on that basics. Let's start, my dear friends, your time is precious. So the first question is that Poisson ratio is expressed as, what is Poisson ratio? How many students can answer? Option A, lateral stress upon lateral strain, longitudinal stress upon longitudinal strain, lateral strain upon longitudinal strain, lateral stress by longitudinal strain. So what could be the answer? I am getting option from everyone. C for Chennai. And same energy you have to be keep. You guys are real mechanical engineers. In the very first class, you have high energy. As time passes, your energy level decreases because of irreversibility increases, entropy increases. So really you are engineers and follow the subject. Try to maintain, reduce the irreversibility, reduce the entropy, and try to maintain your energy high level. In all the class I used to see, you guys are coming live, after that slowly, it is going to decline. So don't follow the that subject rule. In our real life, you have to increase the entropy. No, minimum the entropy. Try to increase your useful work. Okay, my dear friends. So if you talk about the Poisson ratio, so what is Poisson ratio? Suppose that is one of the any object, right? Any object, if you are going to apply the load P, so what is happening? We can say by the application of that force, sir, length will increases. Yes, length is increases. So you can say, but what about depth? Depth decreases, na sir. So initially let's assume this is D1. Let's assume no, that will be D2. Initially its length is L1, now the length is L2. So we can say sir two strain. One is called diametrical strain or lateral strain. We can say sir change in diameter, change in diameter upon original diameter. What about longitudinal? So change in length upon original length, that one. So two types of strain is observed. Now we can say if length is increasing, what will be diameter? What will be that width? Obviously decreasing, sir. Obviously decreasing. So mu is basically, it is the ratio of lateral strain upon longitudinal strain. So sir, epsilon d upon epsilon l. But my dear friends, one sign, minus sign will come. Why minus sign will come, sir? Why minus sign? One minus sign will come there. No question is that why, sir? Because my dear friends, if the longitudinal is increasing, then diameter is going to be decreased. So there is a reverse relation or proportional relation. Yes, we can say reverse relation, no, sir. If lateral is increasing, if longitudinal increasing, lateral decreases. Once if you are going to be compressed, lateral increases, longitudinal decreases. So there is an inverse relation. That's why one minus sign is coming to tell you there is an inverse relation between the lateral and longitudinal. Once increases, other automatically decreases. So that thing you have to be keep in mind. So the correct answer is what, my dear friends? Lateral upon longitudinal, and you guys have given the right answer, Chennai. Okay, now a little bit more about I am going to be discuss. Can anybody can tell me mu can be negative or not? Obviously no, yaar. Mu can be negative? No, sir. If this is negative, suppose here it is positive, my dear friends, so it is negative. When it will be negative, it will be positive, and minus is there, so it will be always positive quantity. Yeah, in some organs in our body having mu is less, but I am engineer, I am not a doctor. I am not going to read about my organs. I am going to read about the steel. I am going to read about the structural member. So I am not going to read. So for in our analysis, my dear friends, mu will be the right from you can say 0 to 0.5. That point you have to be keep in mind. 0 to 0.5. When will be 0? Suppose, sir, if any rigid body is there, so in that rigid body, what will be change in diameter? Obviously no. Yes, 0 to 0.5. Yeah, asu. Fine. It will be, you can say in the rigid body, no deflection is there, sir, in the y direction any. So it will be 0. So I will see. So that point you have to be just keep in mind. Sometimes they will ask why the minus sign is there. We can elaborate, sir, because there is inverse relation. That thing only you have to be keep in mind. Rest thing is fine. That is a strain change in diameter upon original diameter. This is called lateral dimension because that is the longitudinal axis. Na, yaar. So that is longitudinal axis. That is lateral axis. So strain in that direction is on longitudinal. In opposite known as lateral. Now come to the next question. Okay, lot of thing. Here you have to see for the rubber mu is 0.5, for the cork mu is 0.0. So sometimes in the some exam they are going to be asked what will be Poisson ratio for rubber. It will be 0.5. In case of cork it will be 0.0, not 0.0 is still 0. So it will be 0. That thing you have to be given. Come to the next question. Okay, now I am going to give one option here. Option E is also there. What? Elastic limit. Now give the answer of that one. Hooke's law hold good up to yield point, limit of proportionality, ductile limit, breaking point, elastic limit. What will be answer? Everyone? I am getting, what about others? Everyone have to be answered, my dear friends. I am getting here only few answer. What about others? Rest student is getting confused. Okay, no problem. If you are getting confused, still no problem. I am here to clear that things. You know, in the offline classes, not even offline, in online, usually a student is going to be confused about the Hooke's law. Usually they are going to be confused. Sometimes they will elastic, and that thing is also, you can say, confusion of the book is also there. Sometimes they used to say, sir, it will be elastic, sometimes proportionality, sometimes don't know what. So my dear friends, listen that concept very carefully. If you draw the stress strain curve, right? If you draw the stress strain curve for stress strain curve, especially for the mild steel, if you talk, right, B for Bombay. Okay, I am coming. So my dear friends, you can see here, not like that exactly, not that much amount, but okay. So see there, that is point, let's assume O, that is point A, my dear friends, that is point B, that is point C, and that is point D. Okay, let's assume 4 points, just rest is there, and after that is going to fracture. Rest part I have left out. Okay, so 4 point is there, O, A, B, C and D. Keep in mind, my dear friends, in OA is known as proportionality limit. This is known as proportional. What is the meaning of proportional? Means whatever change in strain, suppose I am going to be, strain is double, then stress will be double. That is the meaning of proportionality limit. If strain is half, stress will be half. If strain is 0.1, 0.5 times more, stress will be. That is the meaning of proportional limit. So O to A is the proportional limit. Meaning is that whatever change I am going to do in the stress, same can be observed in the strain. In which region? O to A. That's what you call proportionality. What about A to B, sir? Now, O to A is linear relationship. This is pure linear. This is pure linear, pure linear. Okay. Now, sir, if you go in region A to B, if you go in the region A to B, sir, it is not a linear, sir. It is not a linear. It is non-linear. What the meaning is that, sir? And point B is known as elastic point. If you talk about point B, so this is called, we can say what? Elastic point. Now, elastic. So we can say, sir, in the, if you reach the point B and I am going to remove the full load, body will regain their shape. That is called elastic limit. But in the region A to B, this is not a linear. This is non-linear. What is the meaning of that, sir? Suppose I am going to increase the strain by 3 times. Let's assume randomly I am going to take the data. Not easy, up to the scale. Randomly I am going to take. If strain is 3 times, that not necessary, stress will also increase by 3 times. It could be 2.5, it could be 3.1, right? So my dear friends, that is called non-linear relationship, A to B. And after B, you are getting the yield point. So that is the point yield. Also, it is again non-linear. Now the question is that, sir, if you talk about Hooke's law, then which one is right, sir? So my dear friends, always keep in mind, Hooke's law is best applicable. This is stress is proportional to strain, na. So what is the power? It's proportionality. This is the proportional limit, na sir. That's why Hooke's law is applicable only with respect to the what? A proportional limit. That proportional limit. Now we can say, sir, in the certain book I have seen, in the certain answer, it is given the elastic limit. Why, sir? It is wrong? No, my difference, he is not also wrong. But that is the very, very right answer. This is good, or you can say best answer. Now the question is that, why, sir, elastic limit is given in the book? Certain. Actually, what is happening, my dear friends, if you see the gap between A and B, if you see the gap between A and B, so this gap, especially for the mild steel, is very, very less. I am going to be see on the board, that's why you are saying, no, so it is a huge amount is visible. But actually, if you go to the practice, you will, do practical that things on the UTM, universal testing machine, we can see the gap is a very, 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 very small, my dear friends. That's why in certain cases, I can assume that it is hold up to the elastic limit, but that is not true. But since I am going to be assume, because the gap is a very small, non-linearity is a very small, that's why I am going to be assume. I am going to be assume, but actually it is not valid. Why I am going to assume? Because the length is a very small, sir. Gap is a very small. So suppose in the option both is there, then you have to prefer the limit of proportionality. But suppose in the option this is not there, this is not there, in such case we can go with the elastic limit. Sometimes it is going to be seen in the exam. So try to be remember that point, my dear friends. After that, this is called upper yield point, this is called is what, lower yield point. In the whenever you find the things given in the yield point, that always talk about the lower yield, that I will discuss in the next question. Now my dear friends, come to that one. Array, what is happening here? See, the question is that the relation between modulus of elasticity E, modulus of rigidity D, and bulk modulus K is given by, that the relation is here is given by. Tell me the answer. So, okay, my difference. I am coming on the basic things. There's a three relations. There are three relations. Okay, I am coming. So, see, three term. One is E, one is G, another one is K. E is called Young's modulus of elasticity. G is called modulus of rigidity. K is called bulk modulus. G is called modulus of rigidity. Young's modulus of elasticity. Young's modulus, I'm just going to write elasticity. Okay, one term is also there. Mu is known as Poisson ratio. Poisson's ratio. So that four terms, and most of the time they are going to ask the relation in between them. First thing I want to tell you, what is the meaning of E, sir? What is the physical meaning of E? Anybody can tell me what is? So my dear friends, just little bit I am going to become, then I will, okay, later on I will discuss E. See my dear friends, that is one of the prismatic bar. What is the meaning of prismatic bar, sir? What is the meaning of prismatic bar? A bar having same cross section throughout is called prismatic bar. We can see that bar is there and they have uniform cross section throughout the length, then it is called prismatic, right? So this is the prismatic bar. If I am going to apply the load P, so it will be, what will be change in length? Change in length will be, we can say like that, it will be PL upon A. My dear friends, always keep in mind that equation is applicable only for prismatic bar. Prismatic bar, first thing. Second thing, when load is axial. If anything is other than that, you cannot apply that equation. Always keep in mind that can be applied if the beam is prismatic, bar is prismatic, not beam, and the load is what, axial. This load is passing through the axis, that it can be applied at PL upon E. Now my dear friend, just tell me one thing. If E will be high, so what will be change in length for a given load? Anybody? If E is high, what will be change in length? Obviously we can say it will be very less, no sir. If E will be high, for a given condition, change length will be less. So what the physical significance of E? Sir, E resists the size change. Anybody have higher Young's modulus of elasticity means they will resist the more size change. They will resist the more size change. That is the physical meaning of Young's modulus of elasticity. What is the physical meaning of G and K? I am coming on that one also. Just give 1 minute, my dear friends. There is a three relations that you have to be keep in mind. One equation is coming out to be E equal to 2g into 1 plus mu, or mu is Poisson ratio. Okay, I am going to use here mu. Let's assume. First, another one is what? E equal to 3k into 1 minus 2 mu. Third relation you have to be remember. E equal to 9 kg upon 3k plus g. Now the question is that, sir, how I can remember, sir? In exam I am going to forget. Yeah, I know you are getting forget in the exam. My dear friend, just tell me one thing. Just tell me one thing. E equal to 2g into 1 plus mu. Now tell me one thing, my dear friends. If the speed is 2g, that is just a way by which you can remember. I will give the tips also how to remember the formulas. Because I know at the last of the exam you will find, okay, how to remember some. I am getting the forgetting, getting the confused. That's why we used to give the tips also. So E equal to 2g. Now tell me, if the speed is 2g, then what you will want? It should, if you have a mobile phone, the speed is 2g. So what will you want? You want, sir, speed should increase, na, sir. That's why, my dear friends, we can say E equal to 2g into 1 plus mu. Sometimes student get confused 1 minus mu. No, if it will be 1 minus mu, then it will be the problem. You have to be increased. So we can say, sir, 2g into 1 plus mu. Sir, if there is a 2, sir, so there is a 1. If nothing is there, means there is a 1. Okay. Now E equal to, sir, 3k into 1 minus c here. If 3 is there, so here it will be 2. Here 2, here 1. Here 3, here 2. But 3k to 1 minus 2g, k have alphabetically come at the higher order, so we can say here you have to remove 1 minus 2 mu. 3k 1 minus 2 mu. Now come to the third formula. E. Now I will ask you, Mr. Anyone, go and purchase the mango, 9 kg of mango. So we can say, sir, E equal to 9 kg. 9 kg, you are going to purchase anything. Sugar you can purchase, rice you can purchase, mango you can purchase now. So we can say E equal to 9 kg upon which 3k plus g. Student is also getting confused in the option 9 kg upon 3k plus g. Sometimes it is given 9 kg upon 3j plus k. So student start confusing. What which one is the right answer? So try to remember E equal to 9 kg and with 3k plus g. 3k plus g. First k then g. 3k plus g, not 3j plus k. So that is the way by which you could be remember. E equal to 2g into 1 minus E equal to 2g into 1 plus mu, E equal to 3k 1 minus 2 mu, E equal to 9 kg upon 3k plus g, 3k plus g. So by which way we could be able to remember? Now suppose you have a one object. Let's assume that is the object, right? And they have all the three property. One is E, one is G, one is K. Everyone, if you talk about my mobile phones, they have also three property. One is E, one is G, another one is K. Now sometimes they are going to be asked for any random object, which value will be the more. For any randomly object, if you talk about, my dear friends, for any randomly object, E will be more than G, it will be more than K. Generally, for any object, it will be, you can say generally, for any object. For any object, E more than J, more than K. And alphabetically you can remember which first come E, after that alphabetically which come G and K. So simply we can say, sir, E, J and K like that. Okay. So that way we could be able to remember. Now I will come, what is the physical meaning of K, what is the physical meaning of J, G, all this I will discuss in the next question or upcoming question, all that thing we have to be discussed. Now see that question, that is also a good question. A solid metal bar of uniform diameter D and length L is hanged vertically. Okay. If rho is the density and E is the Young's modulus, then the total elongation due to its self weight is, and some option you have. Can anybody can tell me what will be the answer? What about others? Okay. What option I am going to be get? Rho G L square upon 2E. Someone, everyone is with option Bombay. Fine. You know, sometimes what a student is going to make mistake here in the option, it is not given. See my dear friends. Okay, that is one of the object which has been hanged, right? That has been hanged. A solid metal bar, that is a solid bar, uniform diameter D and length L. Okay, this is diameter D and length L. Hang vertically. If rho is the density, obviously their density is rho, and E is the Young's modulus. Then the total elongation. You know, my dear friends, what a student usually do? A student thinks, sir, change in length is, sir, PL upon A. They usually think, sir, PL upon A. Can you tell me? Here PL upon A can be there? No, my dear friends, no. No. You can answer just now, you have told us, sir, कि deflection will be PL upon A. You are saying no. Why, sir? My dear friends, always keep in mind that equation is applicable only when we can say the bar is prismatic as well as the P. This P is same throughout. If there is a P, there is also P, there is also P, P. So it is throughout the same, you know. But in that case, if load is same, we can, some student can say, yes, sir, load is mg, no, sir, it is same, sir, throughout. No, my dear friends, this is axial, no doubt. this is axial, but load is not same. Here m, if you see there, so the something mass is different, so it will be something different. Here you can say all mass has been considered, no my dear friends. So here mg is acting at that section, mg is acting. If you take another section, suppose if you are there, so what will be there? So it will be again mg, but this will be something different because the mass is something in that region, the mass of only that portion is there. So mass is continuously changing. So in that case load is not same throughout, load is continuously going to be changing because load is equal to mg, m is continuously going to be changed. So we cannot say ki sir here mass is same, so I can write PL upon AE, so student can mg upon LE like that. No, you cannot do. Now the thing is that how I can move, sir. So I will do one thing, I will take a small cross section, suppose that is a small cross section, any small cross section I will take and like dx section, and then after that I am going to integrate 0 to L, then I am going to be get the answer. So if the load is same, you cannot apply. See there, in this case the the elongation due to the self weight is coming out to be rho g L square upon 2e. Elongation due to self weight rho g L square upon 2e. Now I will ask what will be the strain due to the self weight. So strain due to the self weight is given by rho g L upon 2e. So sometimes they will ask this is strain due to self weight, this is change in length due to self weight. So sometimes they are going to ask what will be strain due to self weight. So it will be rho g L upon 2e. Now suppose if I will ask what will be stress due to self weight, what will be stress due to self weight, anybody can tell me what will be stress due to self weight, anybody? So we can say sir stress is proportional to strain, na sir, stress is proportional to strain, na sir, ha sir, stress is proportional to strain. So my dear friends, what is stress? Stress will be sir E into strain. So E, and what is the strain? Sir rho g L upon 2e. So E will get cancelled out, sir. E will get cancelled out. So what the stress is coming? Sir, it will be rho g L upon 2. That is called stress due to self weight. This is what stress due to self weight. Stress due to what? Self weight. So that thing can also be asked. Change in length rho g L square upon 2e. Strain due to self weight rho g L upon 2e. Okay, if you talk about stress rho g L upon 2, one important conclusion here I want to share with you. Everyone have to be answer. That is a good conclusion that you have to be just keep in mind. See my dear friends, this is I have gold. Okay, let's assume this is I have a gold. Okay sir, and I have a silver, sir. This is silver. This is silver. Okay, this is silver. Cross section area is A, and their cross section area is also A. I am going to apply F there, I am going to apply F there in both the case. Now what will be stress? Can anybody can tell me in both the case what will be stress? Everyone can say sir what you are going to be asked, sir, you are making fun, it will be force upon area. Right, you are right. Which force? Internal force. Sir, if you talk about gold and silver, both have same cross section, both have same force is going to apply, both have same stress, sir. They both have same stress. So sir, stress is a geometrical quantity. It is not going to depend upon the body property, right? It is not going to be gold have some different T, steel has silver have some steel, some different T, but both have same. So a one important conclusion that you have to be keep in mind, this stress is a geometrical quantity. Now a student can think, sir, what you are telling, sir? What you are telling? You are telling it is geometrical quantity. See there, stress due to the self weight is rho g L upon E. Rho is density, sir. How you can say, sir, it is a geometrical property? Here, sir, if density will be, if you talk about stress due to self weight, so they have certain different density. They have certain different density. So in both the case, stress will be different. Yeah, right, my dear friends. That was my conclusion. Conclusion that if you talk about generally, they are going to be asked what is stress. So stress is obviously that is a geometrical quantity, not going to depends upon the their property. But if you talk about stress due to self weight, so it is a property, and stress due to self weight depends upon the material property. That question has been asked in service once time, and till now that type of concept note has been asked in ISRO. So I think hopefully they can ask that like that. What is stress? They make a statement 1 and 2 like that, and they will ask some question. I have solved in the previously you have seen. You might have seen that will upload it. That statement type question was there. So like that question they can ask. So my dear friends, keep in mind if nothing is mentioned, they talk about stress. So it is a geometrical quantity. They haven't do anything with the property of the material. Not going to depend, because both have different property, both have same stress. But if you talk about stress due to self weight, so it will be depends upon the property. Now my dear friend, just keep in mind, later on I will teach you thermal stress. Later on I will teach you thermal stress. Thermal stress, this is coming out to be alpha E delta T. So alpha is what? Coefficient of thermal expansion. All stress are independent from the independent from the property of the body, but two stress is only there. Only two stress are there, which is going to depends upon the material property. One is what, my dear friends? Thermal stress. Thermal stress. Another one is what? Stress due to self weight. So only these two stress are there, which going to depends upon the property of the material. Rest different types, whatever stress you know, all are independent from the properties of material. But these two is only which going to depends on the property of the material. That thing you have to keep in mind, my dear friends. That conclusion you have to keep in mind. Other than stress is independent from the property. Okay, that type of question I will come. Then I will again discuss on that things. Now coming to that question, you have to be just remember the value of Poisson ratio for a steel varies form. In case of a steel, what the value will varies form, you have to be answer. Okay, what answer I am getting? Bombay, fine. My different friend, you know steel. So in steel, na, on the percentage of, in the material science it will be taught, in the steel on the basis of percentage of carbon, these are three types. One is mild steel, another one is medium carbon steel, high carbon steel, right? That will be taught in the material science, so don't worry. So they have different percentage of carbon, and percentage of carbon highly affect the hardness of the surface, highly affect the ductility. If you increase the percentage of carbon, na, my dear friends, ductility decreases, brittleness increases, hardness increases by increasing the percentage of carbon. That's why it have a range. In case of steel, you have to be just keep in mind, mu is going to vary 0.25 to 0.33 only, 0.25 to 0.33, but according to given option I am going to be choose option B, but exactly the value is 0.25 to 0.33 it is going to be vary. So that thing you have to be keep in mind. And yeah, you guys have, sir, is it necessary to remember all the value for different material? No, my dear friends. Steel is a very common material to engineers, so it is going to be talk only about the steel, not for other materials. So don't be confused, sir, I have to remember the for all. No, you don't have to remember, only remember steel, rest forget. Cork and rubber, these only, rest you have to forget. No need to be, because in the ISRO they are not going to be things which is just by hearted. This is going to ask the thing where concept is involved, where you need to apply the different types of concept, that type they are not going to like that. But okay, just for being safe I am going to take the some important question like that. Here some is value is there, but no try to remember, you don't have to remember that data. Now that is the next question. Okay, see, the deformation of a bar under its own weight as compared to that when subjected to direct axial load equal to its own weight will be. They have some question and you have to be start, you have to be answer, and your time start now. You have a 30 second. What answer is coming out to be, my dear friends? Waiting for your answer. Okay. What about others? Hmm? So very easy things here you can do now. So deformation, right? That is the one of the object. What will be deformation means change in length, they talk na, the deformation of a bar under its own weight compared to. So what will be change in length? Just now you have seen rho g L square upon 2e, that is due to self weight. What will be rho g? This is called a specific weight na. What is rho g, my dear friends? This is called a specific weight. I am coming to the answer. Let me check your answer. So deflection due to point load is given by PL upon A. Deflection due to self weight, rho g PL, rho g. Okay, P, they have given the same load which is equal to that one. Same load, both P is there na. So it will be PL. So the ratio is coming out to be half, right? And most of you guys have given the right. In the case P, so it will be PL upon A if the P is there. Deflection due to self load, you can say self weight is what, if P is there, so PL upon 2A, and that from it we will get the answer. Which A is there or missing? Just 1 second. Okay. Take this question. A steel bar 40:40 cross section is subjected to axial compressive load of 200 kilonewton. If length of the bar is 2 meter, is that one? Easy question. Very easy question. I think everyone can do that. Question has been asked in ISRO. That's why I've taken that question has been asked in ISRO. That's why I've taken that question. But easy question you can do. What will be change in length, my dear friends? You can say, sir, a steel bar of 40, okay, cross section is same throughout, okay, subjected to here axial load is also there, so prismatic and axial, I can say, sir, PL upon A. The elongation of the bar is going to be a change in length. You have a data, you have to be just solve that. By solving, how much it is coming out to be, my dear friends? Anybody has solved that one? PL upon A. So what the P is given? 200 kilonewton, sir. So 210 to the power 3, here Newton is there, upon PL. L is how much? A 40 itna square cross section subject to axial itna. If length of the bar is 2 meter, so length of bar is 2 meter upon PL upon A. A will be 40:40, 40:40 into 10 to the power minus 6. Convert in the meter cube. 10 to 3, 10 to the power 3 minus 6, fine. E is given 200 gigapascal. So 200 into 10 to the power 9. Fine, sir. Now solve that one. Now solve that one. By solving that, how much it is coming out to be? 1.25. If you are going to be solve it, we can do that here. 200, that is cancel out. That, right? So it will come in the meter. It will come in the meter. Now 2 upon, we can say 2 upon how much? 40:40 is coming out to be, or you can say 1 upon how much? Mm na, multiplied by 1000, so we will get the mm. Multiplied by 1000, we will get the in the mm. So that 0, that 0, that 0, that 0 will going to be cancelled out. 20 upon 16. So 1.1 16 is what? 4. 16 duna 16 to 32. 1 point. Yeah, A will be the answer easily. So it was easy question, but going to be asked. It has been asked in an exam. That's why I've come with that one. Now take that question. Okay, that is another good question. That question not has been asked ISRO. In ISRO till now, that is not asked. But in all the different exams, that question has been asked. So let's see this year what is happening. Till now, not asked in the ISRO. So I am getting the answer. Most of you guys have given the right. That is a good thing. Most of you have given the right. Most of you know. In fact, all of you have given the right. So try to remember that one, my dear friends. See there, just I want to tell you. Suppose that is one prismatic bar. So if the prismatic bar is, so diameter will be same throughout. This is D. So what will be the, change in length, we can say sir PL upon AE, you know PL upon AE. So what will be E sir? So PL A हो जाएगा pi by 4. This is D, this is D. So D square, can I write D pi by 4 D square E, can I write? Yes sir. So what will be? We can say sir 4 PL upon pi D square means D is to D is to E. Why you are going to write like that? Okay, I am just telling you. Now suppose one I have prismatic bar, okay, that's I have, let's assume not prismatic, non-prismatic bar is there, and I'm going to apply the load P there. So what will be deflection there? Deflection will be same, it will be also PL upon AE, but here 4 PL upon pi, but here this diameter is D1, this diameter is D2, so here D1 D2 was same, D1 equal to D2 equal to D, here we can say D1 D2, but in this case D1 equal to D2 equal to D, that's why I'm going to write D. But here, so D1 D2 is different, so I have to write pi D1 D2 into E. Sometimes the question going to be asked, my dear friends, if prismatic bar is there, sorry, a non-prismatic bar is there, you have to be convert that bar in the prismatic, then what will be the ratio, what will be the relation in the diameter? So my dear friends, we can say sir, if everything is same, so can I say D square, if I am going to compare both these two, so can I say D square equal to D1 is to D2? Why not sir? Why not sir? Obviously I can say. So D is equal to coming out to be root under D1 is to D2. My dear friend, that relation you have to remember, might be asked in the upcoming exam. The question will be that you have to be convert non-prismatic bar in a prismatic bar, okay, then what will be the diameter of that prismatic bar? It will be equal to the mean of the non-prismatic bar. Diameter of the prismatic bar will be equal to the mean of the non-prismatic bar, keeping in mind that deflection in both the member is same, deflection is same, load has been applied same, rest thing is fine. In that case, diameter will be equal to root under of D1 and D2. That question may be asked in upcoming exam, so be ready for that. Fine. Okay, that is another question on the ratio. Today, just I am going to talk about the only elastic property question. Tomorrow, I will see the stress session question, then Moore circle, complex stresses, pressure vessel, then SFD BMD, and then torsion, bending, deflection, and then at the last, we'll discuss the columns. Right. So if the Poisson ratio is given, I don't think you guys will find any difficulties to solving that question. That question is again has been asked in ISRO. But okay, some question is coming easy, so no problem. I know modulus of E and G. So we can say that E equal to 2G. Now 1 plus or minus 2G na sir. So 1 plus mu. In the question, every data you have, my dear friends. I don't think anything we have to do. 2G into 1 plus mu is given how much? 0.25. From there we will get the relation between G and A. Chennai. I think you guys are going to give the answer Chennai. Let me check. Chennai is the right answer. Good. Oh, okay. It was not a. No, don't don't what? You don't have to be appreciate yourself. Oh, I have solved that one. No, that was easy question. Anyone can do if they have remembered the formula. When you have to appreciate, you have to be appreciate in that question. When I tell you, my dear friends, think and try to answer that one. If you are going to be answer that type of question, yes, really you have to be appreciate yourself. You are doing something in the better way. If the radius of wire is straight, same, no, same means answer. Tell me, if the radius of wire is stressed by load double, then Young's modulus will be some option you have. Give the answer fast. Waiting for answer. So okay, someone is coming with option Chennai. Someone is coming with the option elephant. Okay, what about others? Someone is coming with option Chennai, Bombay. Yeah, you guys are real democratic people. Really, you guys are pure democratic people. Why? I used to say democratic, because you want to be every option. Otherwise, option will think okay, they are not going to give me priority. So you are going to give priority to all the options. That's great. And only because of you guys, like you of guys, our democracy is running. Same, not change. Okay, so becomes half, becomes 4 times, double, half become 4 times, become 1/4, none of the above. And yeah, now good thing is that, my dear friends, most of you guys have given the right answer. That is a great things. That is the great things and good. So my dear friends, sometimes what the student think, they think, so if the radius of wire is stretched by a load, Fergie, all are there. My dear friends, you can say now, sir, stress is proportional to strain. According to Hooke's law, stress is proportional to strain within elastic limit. Fine. My dear friends, if I will ask, if I am going to double the stress, what will be a strain? Sir, it will be double. If I am going to reduce the stress, what will be a strain? What will be a stress? If I am going to reduce the strain by 50%, stress will reduce by 50%. Yes, sir. So if I am going to remove that proportionality, so what if you are going to remove the proportionality, E will be, then E is coming, and E is Young's modulus of elasticity. Now tell me, if I change the stress, what change coming in the E? Sir, nothing, sir. If I change the E, strain will get changed accordingly. If I change the strain, stress will get accordingly. There will be no change in the E, sir. So the correct answer will be E for apple, none of these, or it will remain same. And one more thing, as Mr. Asu is telling, sir, E is the property of material. Yes, my dear friends. Just earlier, before a few minutes earlier, I have told you, E is the property of material which resists the shape, size change of the object. So it is the property of material. It is not going to depend upon the what load you are going to be applied. Getting or not getting? So here it is a proportionality. From that we can think, if I increase that one, same amount it will be increased. There is no change on the E. So by applying the load, half, double, anything you are going to be do, by doing that, it will not going to be changed. So the correct answer will be E for elephant is the right answer. Now that is another question from the thermal stress. A steel bar of 5 meter is heated from 15 degrees Celsius to 40 degrees Celsius. And yeah, that is the first class of the heat engine mechanics. When I started that, I have discussed that time, if you have remember. What will be answer? My dear friends, what is the keyword of that question? The keyword is what? Free to expand. That is the keyword of the question. If you are free to expand, there will no stress. I used to give the example in my class. Suppose you want to be talk with loved ones, okay, and no one is restrict you, so you will not get any stress. No one is here to restrict you. But if suppose you want to be talk with your loved ones and your parents is totally against of that, then what will happen? So a lot of stress will develop. So if you're free to expand, no stress will come. And obviously we can think, in the first class I have told you, sir, stress is coming because of the internal resistance force, na sir. If I am going to be heat, and later on in the thermal stress, if I am going to be heat, no any internal force is developed. No, it is free to expand. But yes, once I am going to be resist like that, I am going to be restrict like that. In such case, you can observe the stressor. In that case, you can stress is observe, because they will try to expand, but that will not allow them to expand. So in the first class of the mechanics, I have discussed everything. Right. So what the answer? A for apple is the right answer. Tell me, is there any student who haven't attended the mechanics classes till now? Here means in our live classes currently, which watching. Have you? Everyone have gone from the first lectures or not? Tell me, anyone is there? Means all of you have attended. Then why only few answers coming there here? All have to be answered, na? Hmm? So my dear friends, whenever anything is free to expand, na, stress will not generate. Stress will not generate. Anytime you can think stress will come if anything resistance force will be there. If free to expand means no stress will come. So the correct answer will be what? A for apple. Later on again I will discuss in that type of question. In the thermal stress chapter will be there, thermal stress. Then I will discuss what is that question here. It is looks like longer question. Give the same answer, I think same question as earlier, I think. Just read. Same question as earlier, I think, huh? But that is in the language form. And circular rod of length L and area cross section A has modulus of elasticity E and coefficient of thermal expansion alpha. One end of the rod is fixed and other end is free. Fine, good. One end is fixed, other end is free. Well, if the temperature of the rod is increased by delta T in the rod, okay. So this is the free to expand, no sir. End is free, so that is free to expand. So from that I can say stress will be 0, sir. But strain, na? Suppose my dear friends, if this is the rod and you are going to be heat, free to expand. One side is means this is like that, yeah, this is like that. So that can, in that way it can go. So it is free to expand. Now if you are going to be heat, so the change in length is observed, na sir. So strain is coming, na sir. Sir, strain is coming. Strain is coming, but in that case stress is not come. So good thing is that you guys have given the what? What is happening? See, we can say, so thermal stress is given by E alpha delta T, right? E alpha delta T, right? E alpha delta T. So what will be the, we can say, sir, stress is proportional to strain, no sir? So E alpha delta T is equal to E into strain. This is strain. E will get cancel out. So what will be the strain? It will be alpha delta T. This will be the thermal strain, alpha delta T. And what is alpha? Alpha is basically, we can define later on in the thermal stress I will discuss. Alpha is called coefficient of thermal expansion. Basically alpha talks, that is the, simply we can say that temperature by which a body change their temperature, by which body change unit deflection with a given temperature, with that change in temperature, or you can say alpha is that much amount of, we can say what, my dear friends, thermal expansion, coefficient of thermal expansion. So it is a constant. Basically it is just, we can say, so whatever temperature is needed to get unit deflection, basically this is called their coefficient of thermal expansion. So it will be E alpha delta T. Alpha delta T will be the strain. Now see the option, option A. Sir, so both stress strain develop on the rod 0. No, stress develop in the rod is E alpha delta T, strain develop, nahi, that will not there. Stress develop in the rod is E alpha delta T, strain develop in the rod is 0. No, the correct answer will be A, stress develop in the rod is 0 and strain develop in the rod will be alpha delta T. Stress generate is what? E alpha delta T. Okay, now see there, my dear friends. Okay, I am going to discuss now. I want to discuss one important point here. See, just listen one thing. I want to tell you one story. That story is what, sir? Suppose that object is there, light. Yes, sir. That is there. And I am going to be heat them, sir. I am going to be heat them. Okay, sir. I am going to be heat. So what will be stress? Sir, here stress will be 0. This is free expansion. What will be strain, sir? It will be alpha delta T. Case number 1. Now suppose, my dear friends, this is the case number 2. Now it is restricted in x direction totally. Now this is completely restricted. I am going to be heat them. I am going to be heat them. What will be stress? In that case it will be E alpha delta T. What will be a strain? Sir, in that case, if you talk about in the x direction, no strain is there, but in y on z direction, some strain will be there. I will come on that point. No, thermal stress we have seen. Now, my dear friends, suppose someone can do like that, no, sir. That is the object, sir. That is the object. Fine, sir. That is restricted in the x direction. Right. This is the object. I have restricted in the x direction as well as I have restricted in the y direction also, sir. It is restricted in the y direction also, sir. It will be restricted in the y direction also, sir. Now it is free to expand in z direction only. So that is the object. If now I am going to give the heat, it will free to expand in the what direction? Perpendicular to both direction, because it has been restricted in the x and y direction. It is free in the perpendicular to both direction. Now what will be stress? Can anybody can tell me stress should be higher than that or lesser than that? Tell me, yaar, it should be higher than that or lesser than. What you think? You are getting something thinking now. In the first class I have told you, you have to think like a scientist. So if you are, it is restricted in the x direction, it was E alpha delta t. No, it is restricted in the two direction, it should be higher, no sir, it should be higher. So what will be that value? This is just a way, my dear friends, we can say, sir, E alpha delta t upon 1 minus mu, or 1 minus mu, whatever. This is, 1 minus mu. 1 minus mu is coming out to be 1 minus, not plus. If it will be plus now, then it will be decreases. Use the common sense. If in exam you are getting confused now, think okay, in the one direction it was E alpha delta t, sir have telling it's a two direction, so it will be more, no sir, it should be more stress, right? You have a two no girlfriend, you have two loved ones, two loved ones, huh? If your parents is restricted one, you will get a higher, you will get the pressure. Now if your parents restricted to top, both of them, your pressure level, your stress level will be increases, right or no? Same thing here, stress increasing, E alpha delta t 1 minus, don't be confused here plus, it will be 1 minus. Okay, getting, sir. Now suppose one object is there and it is fixed from all the three directions, sir. So this is the object and it is fixed from all the three directions. In the x direction, in the y direction, in the z direction also it is fixed, sir. In z direction also it is fixed. Now if I am going to be hit, what should be stress? It should be higher than that or lower than that? Tell me, my dear friends, it should be higher than that or lower than that? It should be higher, sir. It should be higher. The value will be, my dear friends, it will be, see, listen, E alpha delta t and 1 minus, when it was restricted in the one direction, two direction, it was mu. When it will be restricted in the three direction, it will be 1 minus 2 nu. Getting or not getting? It will be 1 minus 2 nu. So see, getting here, it will be 1 minus 2 nu. So all this, when it is restricted in x direction, E alpha delta t. When it is restricted in two direction, E alpha delta t upon 1 minus mu. In one direction, no mu. In two direction, 1 mu. If it is restricted in the three direction, it will be E alpha delta t. 3 is there, so here 2 will be 1 minus 2. Don't be confused, sir, plus 2. If plus will be, then it decreases. If denominator decreases, overall quantity. If denominator increases, overall quantity decreases. So you know the stress will be higher and higher and higher. Highest will be in the three direction. So it will be 1 minus. Don't be confused in the exam. You can think, sir, why you are going to focus that much amount, sir? Why you are going to waste your energy? I know. In the exam option will be 1 plus. Then you start again. You are how to do, yeah? I know E alpha delta t 1 upon something. But what something? What something? So you have to be focused on that one minus plus. That's why I'm taking that much amount of your attention there. 1 minus, 1 minus, 1 minus. Why? Because it should be high. That's why. Okay, fine. So try to remember all that point, my dear friends. In the obviously upcoming session, I will take question on all that. But okay, please don't ask to me that thing, sir. Sir, how it is coming, sir? How it is coming, sir? Tell me E alpha delta t. Okay, I can do that one if you will tell how it is coming. E alpha delta t, how it is coming. I can say that one. Okay, one more case is there. You know, my dear friends, one more case is there. This is called partial expansion in the thermal stress. Now, thermal stress is completed totally. Okay, one basic concept is left there. That is, connection of the shaft. Otherwise, that gets completed. No, the question is that, my dear friends, suppose that is one of the rod, right? This is some gap. The gap is what, my dear friends? A, right? And you are going to be heat them. You are going to be heat them like that. You are going to be heat like that. Okay. Now I will ask what will be a stress. Then what will be answer? What will be answer, my dear friends? If now I will ask what will be the stress, then what will be answer? Anybody can tell me? You can unmute yourself also if you want to be answer.
Till elongation is A, there won't be any stress. After that, there will be stress, sir. Thermal stress.
Right. We can say, my dear friends, see, if we are going to be heat them, so what will be a strain? So everyone can say alpha delta t. Now see, if alpha delta t is less than A, so is there any stress? No, it will be fluid expansion, sir. If strain, not strain, so that should be change in length, L alpha delta t will be better. Note the strain change in length. Right, change in length, it should be a. So okay, if it is a, fine. Alpha delta t, let's suppose a is, let's assume any quantity 7 mm, let's assume the gap is 7 mm and this is coming 6 mm, this is coming 6 mm. Is there any stress will develop? Obviously no, it will be free to expand, sir. It will be free to expand, right? Now if the case is like that, my dear friends, no stress, no stress will develop. In the, one time I will come with this slow question. They have given huge data was there. They asked what will be the stress, and when the student is calculating that one, the alpha, this quantity was less than a, the answer will be 0. I will come that question tomorrow maybe. So that huge data was there. Student obviously stuck. Okay, how much data is there, how I can do? Just go on the basic things here. One doubt which arises. Why? No, in the UTM na, Asu. In the UTM, if you are going to perform the universal testing machine na, you are going to perform on the UTM, then at the upper yield point na, the sharp curve is coming. So exactly I am not able to get that point. I am, when it is coming down, then I am going to be get the value. That's why in UTM, if you are going to be perform, you get the lower yield point, not the upper yield point. That is the, you might have done that experiment in your college if you have done, otherwise no problem. Just listen, go through the YouTube also, you can check that. This will, when the machine is coming, UTM machine, if you go through, so the point A, upper yield, it will come for a very shorter time, Mr. Asu. It will come for a very shorter time. You cannot get that value. But once you reach the lower critical point na, there you have sufficient time to get the value. That's why it is happening. Clear? So that doubt why we haven't asked in the, earlier in the between the session. Whenever you are getting doubt, same time try to ask, otherwise you will forget. Right? Fine. Clear na? Because we can say if the interview they are going to be asked, we can say on the UTM machine, sir, when the upper yield point is coming na, for that particular time is a very less. I cannot measure that value, sir. That's why I'm getting the lower yield point itself. Okay, but now suppose, my dear friends, if the thing is something like that, a is less than alpha delta t, or we can say alpha delta t is more than a. So what will be stress? We can say, sir, alpha delta t. No, stress will generate, obviously, sir. Obviously, it will generate, sir, because strain, this gap is more than a, so they will come there and they will try to what? Push them. So stress will generate here. Now the question is that how much stress, sir? How much stress? My dear friends, anybody can tell me how much stress will develop? Don't try to buy hard, work with the basics. We can say, sir, thermal stress will develop, sir. Yes, sir, I know. It will be a stress into a strain. It will be E into a strain, right? Stress equal to E into a strain. Sir. So what is a strain, sir? What is the strain which is restricted? So we can say, sir, suppose that is coming out to be 8 mm. Let's assume that is coming out to be 8 mm. And this is A is 7 mm. So can anybody can tell me how many deflection is resisted? Obviously we can say, sir, I am strong in the math, don't check me. 1 mm restriction, 1 mm, deflection is restricted, right? It is coming 8 and actually is what? 7. So stress will come because of which one? So we can say 1 mm. So it will be, simply we can say, sir, I think this will be, if we talk about, this value will come out to be E. Instead of strain, we can say change in length upon original length. So E alpha, okay, delta t, L alpha delta t, L alpha delta t minus L alpha delta t minus how much gap? L is there and upon E, some upon L, that equation something will come. So okay, and one thing you have to be just think in mind, ki sir, just do one thing, stress equal to E into strain, just see how much strain is restricted. Sir, 1 mm is restricted, accordingly put the value, you will get the answer. So in the tomorrow class I will take all that different types of question, so you have to be ready for that. Tomorrow class I will take all that type of question. Before that, first today my target is to complete the elastic property chapter. That's why I haven't came with that question. So tomorrow I will take the simple stress and thermal stress. So I will take all that type of question. Give the answer of that one here. Very easy question. I think anyone can do that. That question of the ISRO. Everyone can do now. What answer is coming out to be, my dear friends? Geon. Aspergion. Really, you have to become, okay? What answer is coming out to be another student? So, okay, Chennai. I think, let me check the answer. Easy question it is. I don't think will not find. Chennai is the right answer. EJ relation. You know E and J relation. Just put that value. E and E equal to 2G into 1 plus mu. 2G into 1 plus or minus? 1 plus. And from that we'll get the answer. Okay, get that question, but do not need to waste your time. Yes, give the answer. A material has a Young's modulus. This is given 1.25 into 10 to the power 5 Newton per mm square, and Poisson ratio is given 0.25. The bulk modulus of material. What will be the bulk modulus? That thing is going to be asked. Your time start now. You have just 1 minute of time. 30 seconds? No, 1 minute. Okay, we can take 1 minute. Done. What answer is coming out to be, my dear friends? Bombay. Let me check. Yeah, Bombay is the right answer. Again, it was the same. But that time you have to use the K equal to, simply we can say 3K into 1 minus 1 minus 1 minus 2 mu. 3K 1 minus. So all different types of question on the property you have completed. So from tomorrow I will start the stress strain and thermal stress. Okay, now solve that question. A 200 150 mm steel block is subjected to hydrostatic pressure of 15 megapascal. The Young's modulus and the Poisson ratio of the material is that 200 and 0.3 respectively. The change in the volume of the block. So you have to calculate dV, change in volume of the block. So can anybody can tell me what value it is coming out to be? What is coming out to be? Not. Get not done. Done those? No. Delhi. Balaji. Okay. What about others? So my dear friends, simply we can say, na sir, change in volumetric strain of the block. What is volumetric strain? What is? See, my dear friends, volumetric strain is given by, please try to remember, sigma x plus sigma y plus sigma z upon E into 1 minus 2 mu. That is volumetric strain. And this will be dV upon V, right? This will be change in volume upon original volume. So, sir, this is the case of hydrostatics, na sir? So, hydrostatics, suppose you are going to put one object in a fluid like that. If anybody, you are going to put in that fluid, no? So, pressure will be same from all the direction. Right now, aspersion, it will be same in from all the direction. So we can say, sir, here sigma x is equal to sigma y is equal to sigma z is equal to sigma, and all will be equal to 3 sigma. If you are going to add sigma, sigma plus sigma, so it will be 3 sigma. All will be equal. It will be all will be equal. In the question, it is given. In the yeah, little bit calculation. That formula you have to remember, my dear friends. Sigma x plus sigma y plus sigma z 1 minus 2 mu sigma x sigma y sigma z all are there is equal to the hydrostatics condition that is given in the question. Just put that value, my dear friends. Okay, so change in volume upon 3v upon E into 1 minus 2 mu. Just put the value, it is coming out to be 90 mm. D is the right answer. So how many student has given that answer? You know, my dear friends, what one thing? Okay, D. Fine, everyone here do focus a little bit to work on the calculator part. That question of the ISRO. So you have seen now which type of question has been asked, calculation. So from the day to day, because you know calculation, that thing you cannot improve in a single day. So from the day to day, try to take that type of question and try to solve manually. Don't use the calculators, huh? Then it will be improved. Not at the exam, na, you will get, or you know, as in the first class I have told you here, that mostly numerical you will find in that exam. You cannot protect yourself without numericals. That is the reality of the ISRO. Na, okay, sir, few numerical will come, I will left out. Few theoretical will come. If you are going to be left out, ISRO is going to left you out you. So you work on that here. Really start practice that type of theoretical. Sometimes 0.8 power square is coming, 0.3, 0.25 power is coming, 2 is coming, like that. So I know you have a mentality to solve by using calculators, but it will not be there, na? Then we will get stuck. So work on that from the day to day. From the very start, from the very start of your preparation, you have to be practice that type. So at the exam, will not get difficult in the start. That's why I am coming on that type of question. I know it will take some time in the class, but I know if you practice, and also my dear friends, in the class also don't use the mobiles. I am not saying you, but try to don't use your mobile phones for the calculation purpose, or calculator, don't use the calculators. Do manually. Okay, it will take some time, but slightly it will increase here. As you do now, slowly it will increase. Initially it will take time, but don't worry. Like that type of question. Okay. So my dear friends, yes. So now anyone have any doubt, please ask. If anyone have any doubt, we can ask. Otherwise, we'll meet tomorrow again at 6:30 p.m. with the simple stress and thermal stress. Tomorrow I will discuss the simple stress strain and thermal stress. These two chapters tomorrow I will discuss with different types of questions, and we'll see the some question which I may ask ISRO also on that particular topic. So my dear friends, if anyone any doubt, please ask. Otherwise, thank you for today. We'll meet tomorrow at 6:30 p.m. Till now, what you have to do, you know, your mechanics is get completed. So start practice the questions. And as earlier I have told you, if you are finding difficulties, don't be hesitate to reach out me. Don't be hesitate. Solve the question. Send me the if you are getting difficulties. Work start. Don't think okay now I will do the SOM, then I will do the mechanics. Once you leave the work for the next day, na, and you have a tendency to do like that, at the end you have a lot of works and you cannot be completed. So I don't know how to you take the time, how you have to manage. That all are excuses, I think. You have to manage. If you have start your preparation, you have to manage all that. If you just going to be excuse, sir, I don't have time, I am working, okay, then you are a best general student. That all have some problem here. Everyone have some problem, but the winner will be that one which can face and take the time for their study purpose. Then only we can do. So try to work on that. Now try to solve the mechanics question that you have already has been covered. And yes, you are getting the difficulties. Send me question. One thing I want to tell you, I will respond. Obviously, I will respond to your doubts if you are going to be asked. That not instantly, but it will be definitely. Don't think instantly I am going to respond, but obviously I will respond. Okay, my dear friends, thank you. Good night. We'll meet tomorrow. Thank you.